speaker is Ikkaku Kawaguchik, who will be talking about a study on gaze direction, perception, and face image displayed on a rotatable flat display. Go ahead.
Thank you, Chairman. I am Ikkaku Kawaguchik, and my co-authors are Hideaki Kuzuoka and Yusuke Suzuki. Today, I would like to present our study on how people perceive the gaze direction of a remote person displayed on a rotatable flat display, like this. It's me. As an aside, in this presentation, I use my own photo more than 20 times. I have never seen such presentation. So only this opening slide, I replaced my photo with this Korean pop star. Thank you. Okay, let's start. As you know, gaze is one of the most important factors in human communication. However, when people communicate through a video communication system, the gaze direction of remote participants cannot be represented properly. One of the main factors is the Mona Lisa effect. For instance, her eyes appear to keep following you even though you move around. This effect is a problem. During multi-party meeting, it is hard to tell who the remote participant is looking at. Even when there is only one person in the local site, it is hard to tell which object the remote participant is looking at. Researchers tend to assume that a telepresence robot solves this problem. This is an example. A remote participant can look around by rotating the face display unit, and it seems that the orientation of the face display is effective in showing the remote participant's gaze direction. However, as you see here, we are aware that combination of display orientation and face image orientation make it difficult to read the remote participant's gaze direction. In fact, some researchers like Anstis and SIGCHI have found a similar problem. However, this problem has not been studied in detail. Therefore, the aim of our study is to investigate the effect of display rotation and face image rotation on the gaze direction perception. Now, let me explain our experiment. In this experiment, subjects observe the stimulus shown in here. That is, face image on the display, or in one condition, we show actual person's head. And we ask the subject to answer where those faces seems to look at. Here is a schematic overview of the experimental environment. Basically, the display shows the looker's image naturally looking at 7 targets placed at 0, 5, 10, 30, 45, and 60 degrees. Note that our head and eyes move coordinately when people focus on a displaced target. Both head rotation and eye rotation contribute to the focus in a specific ratio. In this experiment, we especially wanted the looker to show typical head-eye coordination ratio. So we measured the head-eye coordination ratio before main experiment and used the obtained ratio in main experiment. Each subject conducted the experiment under 5 conditions. Each condition consisted of 2 sessions, and one session consisted of 7 randomly ordered targets. We recruited 10 subjects. How the looker's face rotation and the display rotation are combined depends on how the telepresence system is configured. Therefore, by considering different system configurations, we compared these 5 conditions. Note that in all conditions, the subject was instructed to close his or her eyes while the experimenter was changing the stimulus. So the subject did not look at the motion of the display and face image. Condition 1 is face-to-face condition. This condition is the baseline condition for comparing with other conditions. In condition 2, subject looked at the looker's face shown on the flat display. In this condition, this display did not rotate, but only his head and eyes in the display were rotated. Head and eyes rotation angles were controlled according to the head-eye coordination ratio. This condition presumes this kind of configuration on a remote site. In condition 3, head and eyes of face image was fixed on the front, but only the display was rotated. This condition assumes that the remote participant looks at a relatively small display and uses a mouse or a keyboard to control the orientation of the display. In condition 4, both the display and face image was rotated. Head and eyes rotation angles were controlled according to the head-eye coordination ratio. This condition assumes that an eye tracker detects the remote participant's focus angle and rotates the face display to the same angle. In this condition 5, also the head was fixed. Eyes of the face image was rotated according to the head-eye coordination ratio. Instead of head rotation, display was rotated according to the head rotation angle of the head-eye coordination ratio. We included this condition mainly because we wanted to investigate the effect of the looker's eye rotation on the perception of the focus angle. This graph shows the result of the experiment. Each line shows the average estimated angle of each condition. In general, except of condition 3, this line, the results show that the subject tend to overestimate the target angles. As you can see here, we performed statistical analysis, but please read my paper for detail, because I will use up all my all remaining time if I explain all these results here. From here, I'll discuss about each condition. First is the face-to-face condition. Interestingly, even in the face-to-face, the subject overestimated the target angle when the target was greater than 10 degrees. In fact, this result is in line with previous studies, so we think it is okay to use this condition as a baseline. In condition 2, the result was quite similar to the face-to-face condition. For instance, overestimation was observed. Given that the display was not rotated in this condition, this result shows that head-eye rotation in the display has a strong effect to cause the overestimation. We call this effect the head-eye turn effect. Condition 3 shows the strong Mona Lisa effect throughout all angles. In other words, regardless of the target angles, the subject's estimation remained almost 0 degrees. In condition 4, we observed the strongest overestimation. Comparison between condition 4 and condition 2 indicates that the rotation of the display has the effect of shifting the subject's estimation in the same direction as the rotation of the display. We call this effect as flat display turn effect. We think this strongest overestimation is due to combination of the display turn effect and the head-eye turn effect. Finally, let's take a look at condition 5. Compared with condition 3, the rotation angle of the display was made half, and in the display only the looker's eyes were rotated. As a result, even though the rotation angle of the display was decreased, the addition of the eye rotation significantly increased the subject's estimation. It is quite interesting to find that eye rotation has such strong effect. To summarize the discussion, it is clear that the major factor which made these results were head-eye turn effect and flat display turn effect and the Mona Lisa effect. Therefore, when we design a telepresence system, it is very important to take into account these three effects. For example, here's one proposal for a telepresence robot to minimize the overestimation. First, let's compare condition 2 and condition 4 again. Let's assume that the difference between these conditions is the contribution of display rotation, and the result of condition 2 is the contribution of the head-eye rotation. In this example, let's assume that we keep the contribution of the display rotation by maintaining the display rotation angle the same as the original condition 4. Then, if we can reduce the contribution of the head-eye rotation by reducing the amount of head-eye rotation in the display, it may be possible to bring this line closer to this ideal line. In fact, it is not so difficult. This is the system that we've assumed for condition 4. By reducing the display size for the remote participant to 32 inches, we can reduce the head-eye rotation of the remote participant. Some of you may think that using 32-inch display for office work is too much, but don't worry. It is my supervisor. It is way smaller than my supervisor's 40-inch display. Okay. In conclusion, we investigated the effect of display and face image rotation on the gaze direction perception. And we found that both display rotation and head-eye rotation affect viewer perception. Based on these results, we proposed a design implication to minimize the overestimation. That's all. Thank you for your attention.
Once again, if you can come to the microphones behind the pillar there, and state your name and affiliation.
Sorry, I'm sorry, but I hope you can speak slowly.
Okay, no problem. I'm Ignacio from Université Paris Sud in Rio. My question is, do you think that if you would use a fixed display and you would distort the image as if it was rotating, you would achieve similar results? So instead of moving the display, having a fixed display and moving the image inside the display, so distorting the image as if you were moving the display.
Yeah, I think the result will. So I think we should try that, but I think I can't get same result.
So your intuition says that you could get similar results?
No, I couldn't.
Okay.
Yeah.
Okay, thank you.
Thank you.
So just as an aside, we've done some informal stuff, trying just doing a perspective skew on an unrotating display and got very little inherent motion from it. Microsoft Research still.
Yeah.
And so do you envision this being the rotation, the gaze angle being something that's continually adjusted automatically, or continually manually adjusted, or adjusted manually only periodically?
We think I want to automatically focus in future, but now we only only provide a fixed image. But I should move it automatically. Sorry.
Gerrit van der Veer, no affiliation. You did a very nicely controlled experiment, and you showed the different effects of the orientation of the display and the face and in the eyes on estimating the angle. So far so good. But does it really matter? One of my PhD students, 20 years ago, Roel Vertegaal, you might know him, he did a study on with a very primitive kind of technology. This was 20 years ago. The only thing that he could do was put an avatar face, a fixed avatar face on the tile and show the tiles moving, right? And he found out it worked perfectly well. He was aware of the fact that well, this is some kind of Mona Lisa effect you get. It's true, but it worked perfectly well for instance, turn-taking in multi-party conversations. So why should people be able to estimate the angle, is my question. You understand?
Yeah,
I
understand.
mean, what people should be able to estimate is,
Yeah.
am I talking to you or am I talking to him?
Yeah.
Right?
Actually, I also seen the research such showing the only rotating the display and the fixed image, using the fixed image can it is useful to turn-taking on multi-party conversation, but in that paper, the subject answered that he can understand where the display, human in display, is talking at, but if the person in display talking to subject, he didn't feel his eyes is looking at him. So some problem has still remain if rotates the display.
Okay, thank you.
Sorry.